Hacking Exposed, the #1 book on hacker methodology. Mr. Michael Davis.
First I'm going to start off and talk about who I am, talk about what is a client honeypot, talk about some of the client honeypot techniques that have cropped up in the past year or so as this technology has been starting to form. We'll talk about the pros and cons of these techniques and the technologies that they're using, and then also talk about the future and actually an architecture that I've helped create with the HoneyNet project for a new type of client honeypot technology, and then at the end we'll go ahead and handle questions. So I apologize for being a little slow. My laptop, as most Windows machines do, froze, so I had to restart it. So who am I? My name is Michael A. Davis. I'm CEO of Savin Technologies. So Amy actually introduced me working at McAfee, but I did leave McAfee a few months ago. There I was Senior Manager of Research and Development. But now I run my own company, and we have a team of about 10 people that focus on HoneyNet technologies and deploying those technologies for enterprises and governments, as well as application development in general. I'm also a published author. I contributed to Hacking Exposed, which I think many of you know of. I also have some things in IT Auditor magazine and Sage magazine as well. And then I've spoken at a whole bunch of different conferences, DEFCON, TourCon, CanSec West. And I've also developed Snort for Windows, vSniff for Windows, and ngrep for Windows, as well as most of the Windows HoneyNet tools that you may see on the Windows HoneyNet sites. And I'm a senior member of the HoneyNet project, and that's who I'm representing here today as we start looking at these new types of HoneyNet technologies that are coming out. So what exactly is a client honeypot? It's a new term. What does it mean? Well, the age-old term of honeypot in general meant something that lied, that had value, and being probed, attacked, and compromised. So we wanted to put something out on the network that somebody would break into. We'd watch them break into it, and then we'd analyze why they broke into it, how they broke into it, and then try to take those things that we learned and apply them to our own networks to see if we can improve our own security. Well, client honeypots are the inverse. They're the exact opposite of a honeypot. We're not sitting there waiting for something to come break into us, waiting for an attacker to come send us a new exploit or something like that. Rather, we're actively going out into the internet. We're crawling the internet, searching for malicious websites, pornography websites, news sites, whatever it may be, that are exploiting the client application. And this application may be Internet Explorer, maybe Office, it could be whatever you want. And exploiting that application to do something it wasn't designed to do, or the user didn't want it to do. So the example would be downloading malware, a porn dialer or something like that. So we build these systems to go out there and find these sites that are distributing these pieces of malware. So why do we need client honeypots? Well, this morning was actually a great presentation of why we see Microsoft increasing a lot of their security in the user land section of the operating system, and they're starting to prevent a lot of anonymous, unauthenticated attacks in the system. Same with all the Unixes out there as well. So what has happened is the attackers have moved to the client, moved to the application. I can't get into your machine by breaking into it remotely. Maybe I can fool you into running something, or fool you into going to a website that'll make you download something so I can control your machine or do whatever. And we've seen this. In 2005, there was only 5 Office vulnerabilities released. And this number comes from Security Focus. But in 2006 so far, there have been 24. We've seen the researchers have moved now from server-based attacks focusing on the network services and moved more towards the client. So we're talking IE, Office, Outlook, whatever your other client applications may be. So 89% of PCs infected with spyware is another statistic that came out in Q2 by Webroot, which is the #1 spyware vendor. Now, I could be, of course, slanted because they are a spyware vendor, but my time at McAfee shows me that that number is probably close to what it really is. PCs are getting more and more infected with spyware, and most of our dealings with family, what do we have to deal with when we talk to family? It's spyware, it's malware. Now, why is that such a problem? Because there's money in it, plain and simple. And so the client is where these attackers are starting to move to. Identity theft, which is huge, and it's becoming bigger and bigger. You need the data off the machine, right? So forget breaking into the machine. I need to get you to give me information, whether it's a phishing attempt, whether it's something different, to provide credentials. And as we see in the top 10 SANS vulnerabilities, and when they categorize them, 4 out of 5 are actually on client applications, so Office, IE, etc. and then operating system vulnerabilities in general are decreasing. So we're seeing a large number of operating system issues dropping away, more researchers moving towards the client. So we need these client honeypot technologies to help us get an edge on where things are going. Who are the bad guys? How are they distributing this malware? And how can I protect myself better? So the two types of client honeypots follow the same type of categorization that we do with normal honeypot technology, which is high interaction and low interaction. Now, high interaction is what I categorize as something that does, it drives the browser directly, it's not emulating anything, and it's doing a very in-depth analysis of the system to determine what happened. It's not just saying, okay, I found an exploit or something on the site that I've heard of before. It actually does an in-depth analysis of the machine to determine if it's been broken into. And high interaction honeypots can find zero-day attacks as well as known exploits. So these things are not just signature-based, looking for things that everybody knows about. They're finding the newer attacks, things that websites that have new types of zero-day exploits to make you download some malware, they're finding as well. Now, they usually require a virtual machine, whether you're using virtual PC or using VMware, requires some type of virtual machine technology so you can easily roll back to a state before when your machine was clean after the attack has taken place. Now, low interaction is sort of the low-hanging fruit when it comes to this type of technology. It's usually signature-based, so you could be using an AV engine or something to analyze what's happened to the machine, or is this script I'm going to execute, this JavaScript, malicious? But they're very, very fast because of that. They're not looking for changes to the system. They're not crawling across the file system. They're not looking at registry changes. And most people call these like the WGIG of the client honeypots. They're very simply going out there, grabbing doing an HTTP request, grabbing the response, parsing it, and then going on to the next one. And so there's very little analysis here and very little information you can get from these, but they do give you some information, and we'll talk about how they can be used later. So what can these really detect? Why do we care about these? Well, again, it's application level exploits. So i.e. being exploited by, say, a WMF exploit or a JPEG that's messed up and causing you to execute code you shouldn't be. Cross-site scripting issues, specifically spoofable address bars. That was an issue in IE. I think it was earlier this year. So phishing want to use these things. They want to make it look like you're going to a site you shouldn't be, or you should be when you're not. Malware delivery in general. So as Thorsten talked earlier, Thorsten's a member of the HoneyNet project as well. Malware, it's huge right now. Botnets and bots are the biggest thing right now out there because money is into it. And when money comes into things, you're going to see a big increase. The content analysis that comes with malware is really the issue. We're starting to see more and more, and I feel we're going to see more and more, away from just statistical analysis or technical analysis of problems and more towards content. What does this mean to the user? It's going to become very subjective. But client honeypots, because of their subjectivity, can be very useful depending on what type of data you're looking for. A great example we'll talk about later is the Site Advisor service acquired by McAfee earlier this year. They use client honeypots in a unique way to give you data that you probably wouldn't have thought of you could get from a client honeypot. I'm going to stop this before it keeps annoying me. Alrighty. So high interaction. Let's talk about the pros and cons real quick. I mentioned differential analysis provides in-depth details. What does that really mean? Well, a high interaction honeypot is doing a simple operation. It goes to a website. Once it goes to a website, before it goes to it, it baselines the system. It says, what executables do I have? What directory structures do I have? What registry do I have? Goes to the website, and then checks to see if there's a difference afterwards. So you can see that this is very, very slow, but it gives you all the information. You know if you went to a website and it exploited your browser, for example, and dropped a piece of malware on it, and malware was executed, and now you have 14 other pieces of malware running on your machine, you can see where those files were dropped, what registry changes they made, how are they hooking into the system, etc. You get a lot of detail. And these can also be extended past the browser because they're driving a program. They're not just issuing an HTTP request. They're actually driving an application by clicking on GUI buttons, by forcing Internet Explorer or forcing Outlook to open a message, that type of thing. So they can be extended into email, into Office documents, into other client applications. Now, right now, most of the HoneyNet or client honeypot technology is focused on the browser. But I'll talk about later how we need to expand that to focus again more on not just the browser, but any type of medium coming into the user. Whether this is an IRC communication or this is an email communication, maybe an AOL Instant Messenger, message coming across. We got to look at all different types of ways a client can be used to give the user information. Because it does require a driver to run the application, It takes a little bit more time to build these. They're very expensive to develop. There's been only 2 I know of that have been built, and they've been very extensive, take a lot of time and research, one done by Microsoft, to really build these systems to be scalable to get the data we want out of them. That's because there's so much application development going into clicking buttons and analyzing file systems and this type of thing. Now, low interaction, as I mentioned before, is very simple to build. It's very low cost. You get wget, you get a Perl script, you put them together, and there you go. You got a low interaction client honeypot, and you can start doing manual analysis. But they really don't give you much data without manual analysis. So when we talk about what data we want to get out of this, it's going to be very difficult to automate it with a low interaction approach. It requires signature research. So unless you got an antivirus vendor in your back pocket, or you know a buddy who's giving you signatures early, you're not going to know about these issues until after they're already a problem. And if you're looking at things that are already late, you're never going to find a 0-day. Maybe you don't want to find 0-day, but that's something you need to be aware of when you pick these. It can be intensive to build these signatures. A lot of these client honeypots maybe rely on AD or Snort, which is a good example. Those signatures may not be the best ones. They may not work too well. Or you may want to build different ones, looking for something different. These are very scalable, though, because they are so simple. They can easily be put into hundreds of machines across the world and start analyzing URLs and websites very quickly. But they don't work well with non-browser-based applications because you need some type of protocol you can emulate very easily. Email and email interactions are a little bit more difficult than a simple HTTP GET request. Not very, very much difficult, but still something that not a lot of people jump at right away. So I'll go ahead and talk about 4 of the major current client honeypots, and these are ones that you can utilize in some way, shape, or form. Honey Client and Honey Seeds, since they're open source, you can download them and start playing with them. Microsoft's HoneyMonkey, which is a part of the Strider project, is proprietary to them, but they have a lot of white papers about how it works. And McAfee's Site Advisor is proprietary as well, but that's the key I want to talk about with data. So what is the Honey Client? Well, the Honey Client is the first open source client honeypot out there. This was that set the stage. About a year old. It is high interaction. It utilizes a proxy to get all of its data. So it has an HTTP proxy as a Perl script running on the Windows machine. And it has another Perl script which actually loads up Internet Explorer, directs it to a website through the proxy, and then the proxy records all the data it gets, all the HTML, everything that it gets from the responses. It logs it all, parses those, sticks them in another file to go ahead and chew on so it can continually recurse through websites, and it just continually redirects the IE browser. So it's very, very loop-driven, and it's not a lot of collaboration. There's no external components to it. It's all self-contained. Now, the problem is that it's high interaction, so after a site's visited, it takes a long time to do a system scan. It's analyzing the whole file system, the whole registry, every single time you go to one web page. So it does take a little bit of time to actually have information be given to you. It parses the HTML, like I mentioned, which is good because it can continue to recurse. You don't have to manually keep feeding it URLs from either a search engine or some big list you're compiling. But because it only affects file and registry changes, it doesn't catch everything. So it's not looking at memory signatures, it's not looking at what system state changes. So if something happened all in memory, you may never ever see it. It still does require manual analysis once you get down to things. Once you get the data back, it really doesn't tell you what you're getting or what you're looking at. You don't know what bot it is, you don't know what piece of malware it is, you just know something happened. So it still requires a lot of manual analysis, and there's no caching. So you have maybe 50 or 60 of these sitting in your network doing a little research for you. They can all hit the same site at the same time, and there's no communication between any of the devices to sort of collaborate on what URLs are accessing, what websites they've already accessed, when's the last time they accessed them, etc. And then all these 4 different client honeypot technologies I'm talking about are all based on URLs in the web. So none of them have access to email really. None of them have access to any other type of medium like IRC or anything like that. They're all based on the web. But the one good thing about Honey Client is that it's open source. So go download it, go play with it. It runs Perl. It's pretty simple. It is only Windows-based right now, though, because it focuses on driving IE, and that's really where all the vulnerabilities are anyway. Now, Microsoft came out, I think this was about a year or so ago, as part of their Strider project, which is a big security research project they have, a tool called HoneyMonkey. And really it was, I think, derived from the fact that IE7 had this requirement for a phishing filter. I don't know if you've seen IE7, but it supposedly has the capability to help you as a browser know you've gone to a site that could be a phishing attempt. it may be, DNS spoofing or whatever it is happening, and it alerts you right away. This is a